In this lecture, we're going to study the reactions of carboxylic acids as acids and the acid behavior. Now, previously when we studied acid bases and salts, we discussed that acids had a few typical reactions. One was that all acids, they would react with metals. Not all metals, according to the reactivity series, some metals are very reactive, some metals are very unreactive. So if you look at the reactivity series, the reactive metals are going to react vigorously with acids. The unreactive ones are going to react very slowly, or they won't have any reaction. So it depends on the reactivity series. So, but metals react with acids, and they're going to produce a salt, and they're going to produce hydrogen gas. Similarly, that's the first reaction. Then you had a second reaction in which acids would react with bases, and they would produce salt, a water molecule, and that's it. So that was the second reaction. Let me rub this off. So that was the second reaction. The third reaction that acids had was that they would react with acids would react with carbonates, and they were going to produce salt, a water molecule, and a carbon dioxide molecule. And now the fourth reaction was that you had acids, they were reacting with ammonia, which was NH3. So they would react with ammonia and they would produce ammonium salts. So these were the four typical reactions that acids had. And before going on to and understanding what those reactions are, we need to understand what is meant by a few terms that we discussed over here. The first thing is, and we're revising what we did in acid, base, and salts. The first thing is, what is a base? Now, bases are metal oxides, and hydroxides, metal hydroxides, so bases are metal oxides and hydroxides. Carbonates are any substance that contains CO3 minus. They're mostly metal carbonates or ammonium carbonate. So anything that has CO3 minus ion, that's called a carbonate. Now we're going to individually discuss each of these reactions and how these reactions occur with carboxylic acids. Now we're going to study the first reaction in detail. And the first reaction is acids react with metals and they produce salt plus hydrogen gas. And I just told you that metals, not all of the metals react properly with acids. Some are very reactive. So if you look at the reactivity series, where you have group 1 elements are very reactive, so those reactions would be very explosive. Then you have a few transition metals and those reactions would be very slow. For example, gold would not react with acids. So the metals that according to the reactivity series react or have normal reactions, they are, if you look at the reactivity series, they are magnesium, aluminium, zinc, iron, and tin. So what you can do is you can remember this word mazet, where it's magnesium, aluminum, zinc, iron, and tin. So this mnemonic would help you remember which metals are going to have normal or moderate reactions. They won't be very slow or they won't be very fast. So remember, all the rest of the metals, they have problems with acids. Either the reaction is very explosive or the reaction is very, very slow or non-existent. Now we're going to do the first reaction. I'm going to give you an example before moving on to carboxylic acids. Let's do a normal acid reaction. For example, I have HCl, which is hydrochloric acid. And I'm going to react HCl with a metal which is, let's take magnesium, which is in group 2. Now previously I told you how to make salt. A salt is produced when the H acid, let's take this H, this H in the acid is going to be substituted by the magnesium over here. So if I get rid of the H, magnesium is going to take its place, and magnesium is in group 2, so it's going to have a charge of 2 positive. It's 2 plus. So magnesium is going to take the place of hydrogen. Cl is in group 7, so Cl has a charge of 1 minus. So I have replaced this hydrogen over here in the acid with a metal ion. And the formula of this substance is going to be MgCl2, and there's going to be hydrogen gas produced along with it. So I'm going to rewrite this reaction. It's going to be HCl plus we'll have Mg, and they're going to react and they're going to produce this salt, which is MgCl2, and hydrogen gas would be given off. And I need to balance this equation, the two Cl's over here, so I can't change the formula now. What I can do is I can change the number of molecules of HCl, and now it's balanced. There are two hydrogens over here, there are two hydrogens over here. Now the entire equation is balanced. So you have a metal which is reacting with an acid, and it is producing a salt, and there's hydrogen gas being given off. So this is what the reaction is going to look like. And remember one thing, how to make the formula of a salt. You need to be very sure of how you're going to make the formula of this particular salt. Get rid of the H in the acid and substitute it with a metal ion. Now I'm going to do the next reaction with a carboxylic acid, and let's take ethanoic acid, and I'm going to react it with the sodium metal, which is in group 1, and it's a very reactive metal, so it's going to be an explosive reaction. Sodium is in group 1. Group 1 metals are very reactive. So let me draw ethanoic acid first. Ethanoic acid has eth in it, which means there are 2 carbon atoms, and since it's a carboxylic acid, so it's going to have the carboxylic acid group in it. And let's complete all the other bonds. Carbon is going to make 4 bonds in all its compounds, so there will be 3 hydrogen atoms on the left hand side carbon, and I'm going to react it with sodium metal. Now if I react it with sodium metal, so it's an acid reacting with a metal. So you have an acid which is going to be reacting with a metal, and that would produce a salt. And remember, as I previously told you, that to make a salt, you need to get rid of the hydrogen in the acid and substitute it with a sodium metal. In this case, the H that we previously discussed that gets removed is the H in the carboxylic acid group, which is this one. It's over here. It's always going to be this H that would be substituted, because this is, as we previously discussed, that whenever a carboxylic acid behaves as an acid, it's this H over here that gets removed. All the other hydrogen atoms are safe. They're not going to get replaced. So if I redraw or repeat this, this will be, you'll have CH3, and then you will have C double bond O, and this would be O minus 1. The H over here is going to be substituted by sodium metal. That's how a salt is produced. If you replace the H in the acid with a metal, and hydrogen gas would be produced alongside. So this is what is going to be formed. So this substance over here, this is the salt that is produced when a metal is going to react with ethanoic acid, and the name of this salt is sodium. Remember, the positive ion is always written first when you're naming. So the name of the salt is sodium, and the leftover ion, that's the of carboxylic acid, that is called the ethanoate ion. So the name of this salt is sodium ethanoate. So it's very easy to make this salt. If you look carefully, there was ethanoic acid. You had ethanoic acid, you removed the H in the acid and substituted it with a metal ion. So that's the salt that you're going to be getting when sodium reacts with ethanoic acid, and that's sodium ethanoate, and you need to balance this equation. If you look carefully, there are two hydrogens being produced, so that means there would be two molecules of ethanoic acid, and each ethanoic acid would be reacting with two molecules of Na. That means each ethanoic acid would be reacting with one sodium atom, and you will be getting two sodium ethanoate salts, and that would produce two hydrogens that would combine to form hydrogen gas. So that's your balanced equation over here. And let's do a few more questions. Now I'm going to do a reaction of ethanoic acid with magnesium. So ethanoic acid, again, that is the two carbon atoms in ethanoic acid. So this is your ethanoic acid, OH, and I'm going to react this with the magnesium. So let's say, which is another metal. Now what I'm going to get is, I'm going to get a salt and I'm going to get hydrogen gas, and the salt is again going to be this hydrogen over here. It's going to get replaced. It's going to get replaced by magnesium ion. So that hydrogen is gone, and in its place, let me draw the molecule first. So that hydrogen is now gone, and in its place I'm going to have Mg. But the problem now is that Mg is in group 2 and it forms a 2+ sign. So to balance the equation, or so to get the correct formula, that is because oxygen has a -1 charge and Mg has a 2+ charge, the charges on a molecule, they must be equal. So there should be two ethanoate ions, because one ethanoate ion has a -1 charge, which means that it's gaining only one electron, whereas Mg is losing 2 electrons. So there should be two ethanoate ions. One would gain 1 electron and the other one is going to gain the other electron. So there would be two ethanoate ions, and I'll have hydrogen gas with it, which would be produced. So this is your salt, which is magnesium ethanoate. Magnesium ethanoate. And to balance this equation, I would need to have, there should be two ethanoic acids, because magnesium is going to replace two hydrogens. So that would be a balanced equation. Now another way, or a better way of writing this, is the compressed notation of how you're going to write this. You don't need to actually draw all the bonds in this molecule. What you can do instead is, this is CH3, so you can write a compressed version of this. So you have CH3, and then you have COOH, and there are two molecules of this. So you have two ethanoic acids, and it's reacting with magnesium, and it's going to produce this salt over here, which I've already drawn. I've drawn all the bonds, so I can write a compressed notation of this, and this would be CH3. This entire part is CH3, and you have COO -1, and next to it there's Mg2+, and to balance the charges, there should be two ethanoate ions, plus I'll have hydrogen gas. So that's your compressed notation of writing the same reaction. So let's do a few more examples. Let's do a slightly more complicated molecule. Let's draw a slightly more complicated molecule, a molecule that is going to have two carboxylic acids. So this is ethane dioic acid. So you might get questions related to more complicated molecules. So this is ethane dioic acid. If you look carefully, observe carefully, this molecule has two carboxylic acid groups. It has carboxylic acid groups on both sides. Another way of writing this in the compressed notation is that you have two carbons. So there's COOH on one side and there's COOH on the other side, which means that there are two carboxylic acid functional groups. And let's say I'm reacting this molecule with sodium. Now in this molecule, since there are two carboxylic acid functional groups, this hydrogen is going to get replaced and this hydrogen would also get replaced. So there are two hydrogens that will get substituted. So the salt that would be formed in this case would be, you would have C double bond O, and there would be O -1 over here, and there would be C double bond O, and there would be O -1 on this side, and both of the hydrogen atoms would be replaced by sodium atoms. There would be Na plus over here, and there would be another Na plus over here. That is how you form a salt. The hydrogen in the acid is going to get replaced by sodium, and those hydrogen that get replaced, they would form hydrogen gas, and to balance this equation you would need 2 sodium atoms. So the compressed notation for this entire reaction, that would be, you would have ethane dioic acid, which is this one, and it's going to react with sodium, and there are 2 sodiums. So the compressed notation would be that you would have COO-1 on this side, and you have COO-1 on the other side, and Na is going to replace the H at that end, and Na is going to replace the H on the left hand side. So that's your molecule, and hydrogen gas would be produced along with this salt. So this is your salt that would be produced. So you're going to get very complicated molecules. Just remember one thing, that no matter what the molecule is, the H in the carboxylic acid, this H over here is going to get replaced, and this H over here is also going to get replaced by hydrogen.